Hi there. This is the tutorial for the quadratic equation solver, and what I had in mind was I wanted to create a quadratic solver that would put the answers into forms that teachers like, exact forms with square root notations and imaginary I notation, things like that. So I'm going to do a few examples here just to show you how to use it and what it all means, I guess. Let's do a straightforward kind of quadratic equation. Let's take x squared plus 10x plus 24. Now, if you have x squared plus 10x plus 24, your coefficients are going to be 1, 10, and 24. A is in front of the x squared term, b is in front of the x term, and c is your constant. So I'm just going to put that into the program, and we're going to see what we get here. So a is 1, b is 10, and c is 24. And then I'm just going to hit the solve button and see what we get. And as you can see, we get two roots, and what it does is it gives you a kind of formatted representation of the answer. -5 plus 1 over 1 and -5 minus 1 over 1, and then in blue below it gives you the actual answer, which is -4 and -6. So that's kind of straightforward. Let's do a couple more and I'll show you what this thing can really do. Let's do another straightforward one. Let's try -2x squared plus 17x minus 21 and see what we get. And when we do that, we get 1.5 as the first root and 7 as the second root. And as you can see, there's a formal kind of description of the answer on top. That will always be there. That's kind of what teachers want to see. It's kind of like showing your work, more or less. Now with these straightforward quadratic equations, you're not going to see any square root notation, or you're not going to see imaginary notation, but we're going to get into that. So let's do one that has a square root in it and see what happens. Let's try x squared plus 6x plus 2. So we got 1 for a, and we got 6 for a b, and 2 for c. And let's solve that. And as you can see, the answer is in kind of a notation that involves square roots. The first root is -3 plus the square root of 7 over 1. And the second root is -3 minus the square root of 7 over 1 with a decimal approximation below. Again, just an approximation because it's an irrational number. But the first root you get -0.354249, and root 2 you get -5.645751. So it kind of puts it in a form that's kind of nice. And it also gives you that approximation too. Let's try a quadratic that would yield an imaginary root. So let's do 2x squared minus 6x plus 11. Let's see what we get here. Hit solve. And as you can see, the roots are in terms of imaginary. So you have the first root is 3 plus I times the square root of 13 over 2. And the second root is 3 minus the square root I times the square root of 13 over 2. And as you can see, there's no approximation because these are imaginary numbers and the roots really don't exist on the real coordinate plane. So this will give you kind of that notation if you're looking for imaginaries. What the program also does is you can have b equal to 0 or c equal to 0. For example, say you have a question that says I want you to factor x squared minus 81. In that case, the b would be 0 and the c would be -81. So let's try that and see what happens. So in this case, we'd have x squared, so it would be 1. The b would be 0 because there is no x. And the c would be -81. So this would be the equivalent of x squared minus 81. Let's see what we get. And as you can see, we get two roots. We get 9 and -9. So it worked out. Let's try another one. Let's do one that would yield an imaginary number, or imaginary roots. Let's try x squared plus 49. So again, we're going to have 1 in front of the x squared. The b is going to be 0, but this time the c is going to be 49. And then let's solve that. And as you can see, we get 0 plus 7i over 1 and 0 minus 7i over 1. Could also be represented as 7i and negative 7i. And those are imaginary, so there's no real approximation. And then finally, we can do something where the c equals 0. For example, say you had x squared minus 6x. We wanted to factor that. Let's try that. So we'd have x squared, so we'd have 1. And then minus 6x, we'd have negative 6. And in this case, c would be 0. I'll solve that. And as you can see, we get, for the first root, we get 6. And for the second root, we get 0. Okay? And that's about it. The only two buttons are the solve and the clear. If you try to put in a 0 for the x squared coefficient, let's say I do something like this. It's going to throw an error saying that you have to enter valid coefficients for a, b, and c, and you have to remember that the x squared coefficient can't be 0. If it was 0, you pretty much have a linear equation here, and that's kind of a different type of equation to solve, a little bit more trivial. But that's the program, guys. If there's anything you'd like added, or if there's any issues with it, let me know, and enjoy the program.